This is Lesson 2. At the end of this lesson, you will be able to list the key components of a Site Recovery Manager solution, compare and contrast the replication mechanisms available with Site Recovery Manager, describe how to achieve the desired outcome, test, or failover for each use case using Site Recovery Manager, explain the possible dependencies between virtual machines during a failover. Describe the key new and improved features in Site Recovery Manager 5.8 versus 5.5. List the available packaging options for Site Recovery Manager. Click Next to continue to Lesson 2. As described in Lesson 1, there are always two sites required in Site Recovery Manager: a protected site and a recovery site. Because these designations are relative to a specific virtual machine, it is possible to do bidirectional replication and failover between two different data centers for different virtual machines. Other replication topologies, such as many sites replicating to a central site, are also possible. Each site requires its own copy of vCenter and Site Recovery Manager, as well as one or more ESXi servers. There are two replication mechanisms in Site Recovery Manager, namely vSphere replication, a native feature of vSphere, and storage array-based replication, which is based on the native replication capabilities of third-party array vendors. vSphere replication requires at least one replication virtual appliance on each site, while array-based replication requires one or more storage replication adapters, SRA, on each site. Both options and their components and requirements will be discussed in more detail later in this lesson. Before looking at the details of vSphere replication and array-based replication, let's begin with a high-level overview of each. vSphere replication is a proprietary technology developed by VMware specifically for virtual machine replication, with or without Site Recovery Manager. It is included with vSphere 5.0 and later, and can be used standalone in vSphere 5.1 and later. It is a manual process for configuration, maintenance, and failover without the automation provided by Site Recovery Manager. It works with any kind of storage, and the source and destination copies can reside on different kinds of storage if desired. Array-based replication, on the other hand, works using the replication capabilities of VMware's storage partners, such as those shown here. They offer higher performance options and potentially lower RPOs, some even offering synchronous replication for virtually no data loss. Because the replication is being provided by an array vendor, the storage must typically match or be very similar on both sides. Let's look more at the capabilities and benefits of vSphere replication. It is important to note that the replication itself to and from the vSphere servers takes place at the hypervisor VM kernel level, though virtual appliances work in conjunction with vCenter to handle and manage the process, including replication between sites. When specifying the RPO recovery point objective, you can specify a value from 15 minutes, the most aggressive option with the least data loss, to 24 hours, the least aggressive option with the most possible data loss. In addition, vSphere replication in vSphere 5.5 supports multiple point-in-time (MPIT) recovery, enabling you to restore to any of up to 24 previous points in time. This is achieved by specifying the number of points per day to save, and the number of days to retain those daily snapshots, and is separate from the number of replicas required by the RPO. With regard to network utilization, after the initial replication, every replication contains only the changes since the last replication to minimize the time and bandwidth required to synchronize that data. Now let's look at the technical details of vSphere replication. As previously mentioned, replication is per virtual machine. However, it can be even more granular because you can specify specific disks to replicate and others you wish to not replicate, like temporary disks. For the initial replication, you can replicate the virtual machine over the network. If you estimate that replication over the network would take too long or consume too much bandwidth, you can restore a backup or copy the files manually from other media to create the virtual machine on the recovery site. vSphere replication will automatically figure out the differences and only replicate those changes since the initial replication. For every replication after the initial replication, it is always consistent to all of the disks that are replicated, meaning that either all disks get copied successfully or nothing goes. The changes made by the virtual machine between each replication are tracked at the VM kernel level and are replicated automatically without involving snapshots, though reverting to a particular MPIT replica does use Snapshot Manager. Finally, vSphere replication works with Volume Shadow Copy Service (VSS) in Windows, allowing apps to be quiesced to enable application copies of data to be replicated. Now let's discuss array-based replication. For array-based replication to work correctly with Site Recovery Manager, Site Recovery Manager needs to be able to communicate with and control the storage array, rather than hard code how to do so for each partner, which is not very scalable or maintainable. VMware created the concept of a storage replication adapter. A storage replication adapter interfaces with common interfaces within Site Recovery Manager, and is created by each storage vendor to integrate with their own management interface for their specific array. So what does the storage replication adapter do? It is responsible for discovering the available arrays, determining which LUNs are being replicated between them, and then implementing the specific commands needed to make storage visible for every test or recovery operation. It is also responsible for removing it from the recovery site when a test completes. The storage replication adapter is also used to reverse the replication direction after a failover and to force the last synchronization before a planned failover. Site Recovery Manager 5.8 uses the same storage replication adapters as version 5.5, simplifying the upgrade process. Ensure you refer to the Site Recovery Manager compatibility matrix for a list of all certified array-based replication partners. A virtual machine needs to be complete. In other words, to be useful after replication, the entire virtual machine needs to be complete. Likewise, the data store must also be complete. In other words, include all of the LUNs that make it up. This leads us to the concept of data store and protection groups. A data store group, at its simplest, is all of the LUNs that make it up, as shown in the diagram in data store groups 1 and 2. But that isn't enough. If a virtual machine has disks on multiple data stores, then all those data stores must be treated as part of the same replication unit to ensure all of the components of the virtual machine get properly replicated, as shown in data store group 3. Because the virtual machine in protection group 3 spanned 2 data stores. Protection groups are groups of virtual machines that will fail over as a unit. It is the smallest unit of failover selectable. In our example, protection group 1 is for email servers, 2 is for SQL servers, and 3 is for the SharePoint server. Recovery plans, as noted previously, apply to both forms of replication and constitute one or more protection groups that will fail over together. In our example, Recovery Plan 1 will fail over just the email servers, determined to be a high priority that can't tolerate longer-lasting outages, while Plan 2 is for the entire site with all of the protection groups defined. These concepts, data store and protection groups, are only relevant to array-based replication. For vSphere replication, only recovery plans are needed of the components described here. The screenshot shown here shows the way recovery plans look in the web client. The left pane shows a list of all the recovery plans that have been defined. They can be based on department or function or any other way you choose to group them, and any virtual machine can be in any number of recovery plans. The actions that are possible for a recovery plan will vary depending on the current status of the recovery plan. For example, in the screenshot, the recovery plan is executed, so it can't be run again while it is still running, but it could be canceled. We'll discuss more on the key actions later in this course. If a recovery plan is currently running, you'll see an overall % complete status near the top of the window. Detailed step-by-step information, including status and start and end times, are listed below the summary information. Now that we have covered the various components at a high level, let's look at the technical requirements of each when using Site Recovery Manager 5.8. vCenter must be 5.5 Update 2 or later with vSphere 5 servers at each site. Site Recovery Manager requires a 64-bit Windows OS as well as a database to keep all of its configuration information. This database can be an existing SQL or Oracle database, which can be on the same database server but must be a different database from any other purpose. In 5.8, you can now also choose to use the new embedded vPostgres database to avoid the cost and complexity of an external database. Note, however, there is no migration path between database types. If array-based replication is used, the array must have snapshot or clone technology licensed to perform test failovers, and a replication mechanism for all use cases in addition to the appropriate storage replication adapter. If vSphere replication is used, a vSphere replication appliance must be installed on each site. Let's return to the use cases previously described in Lesson 1 and discuss how to accomplish the stated objective of each use case in the user interface. Let's say you want to run a test failover for update or patch testing, or just to confirm that the procedure works as expected. On the recovery site, simply choose to run a test. A wizard pops up explaining what will happen and summarizing the protected and recovery sites, the number of virtual machines involved, and so on. Optionally, recent changes can also be replicated before the test begins to ensure all the latest data and patches are there at the start of the test. Click the Finish button and the test will commence. It is that easy to run a test failover. The next use case is a planned migration. This may be a preemptive migration for a hurricane or flood, or for a data center migration as described in Lesson 1. The process is the same in both cases. This option assumes that both source and destination sites are online and can communicate with each other. You choose to run the migration in recovery mode to initiate a failover instead of a test, and then, as shown here, you select Planned Migration. This will cleanly shut down all the virtual machines on the protected site, perform one last replication of data, and then bring them up on the recovery site. Note that if any errors are encountered, the process will stop, allowing you to fix the error to ensure a consistent, clean failover. The planned migration can then be run again and will only execute steps that have not been completed successfully. The last use case is an unplanned migration. This option is used when an unforeseen disaster strikes, such as an earthquake or a power failure, as also described in Lesson 1. This option will work if the source site is offline, which is often the case when a disaster strikes. You choose to run the migration in recovery mode to initiate a failover instead of a test, and then, as shown here, you select Disaster Recovery. This will attempt to shut down the protected virtual machines and complete one last replication of data. However, it will continue with the last replicated data if that fails, as is often the case. It will then bring up the virtual machines on the recovery site. Note that if any errors are encountered, the process will continue regardless, giving you the best recovery possible under the circumstances. It is possible, by checking the Forced Recovery checkbox, to run this workflow only on the recovery side, assuming the source site is completely inaccessible and/or destroyed. In this scenario, some additional work may be required to get everything working when the original site is brought back online. One of the features of Site Recovery Manager is that dependencies can be set between virtual machines so that they come online in the correct order, with any prerequisite virtual machines being online first. This is accomplished by having up to 5 groups as shown in this example, as well as optional dependencies within a group. Groups are processed in order, with all of the virtual machines in Group 1 starting before moving on to Group 2, and so on. Within any of the groups, virtual machines can start in any random order, or dependencies can be set such that one virtual machine is online before another is started, if necessary. In the example, the master database is brought online first in Group 1, followed by another database server and an Exchange server in parallel in Group 2. Next, App Server 1 is brought online, followed by App Server 2 in Group 3. Following that, both Apache servers and the Mail Sync server are brought online in Group 4, and the process concludes with all of the desktops in any order in Group 5. Note that it is not required to use all the groups. Any number of groups can be used as needed, up to the 5 possible. Now let's look at the new and improved features in Site Recovery Manager 5.8 compared to the previous version 5.5. Some of these features have been mentioned previously, and several will be discussed in more detail in the following screens. The features fall broadly into 3 categories, namely DR for the SDDC, enhanced scalability, and simplified operations. There are 2 new features for DR for the SDDC. Firstly, the integration of Site Recovery Manager and vRealize automation using a new vRealize Orchestrator plugin. This allows DR to be managed by policy when users create virtual machines in vRealize automation. Secondly, when vSphere replication is used, Virtual SAN can be the storage type at either site. The next new feature is in relation to enhanced scalability, where up to 5,000 virtual machines can be protected per vCenter, 3 times the 5.5 maximum. Additionally, up to 2,000 virtual machines can be recovered concurrently per vCenter to reduce the RTO. Finally, in terms of simplified operations, Site Recovery Manager now uses a standard web client instead of the vSphere client. IP addresses can be managed at the subnet level instead of the individual virtual machine level, and as previously described, you can save the cost of a database server by using the included vPostgres database. Let's expand on the self-service, policy-based DR capabilities that are now possible with Site Recovery Manager, vRealize Automation, and vRealize Orchestrator. From an architecture perspective, Site Recovery Manager must use array-based replication, not vSphere replication, and vRealize Automation management must span both sites. Also note that Site Recovery Manager can also be managed via Power CLI. As for the actual self-service capabilities, vRealize Automation enables self-service using blueprints, which define the Site Recovery Manager configuration, virtual machine location, etc. desired when a user deploys the blueprint to create a virtual machine. The user can even specify which Site Recovery Manager group, essentially a priority, the virtual machine will be started in, as described earlier. Why is this a big deal? This enables end users to know that the workloads they create are automatically protected from disaster. This also reduces the complexity and workload for infrastructure administrators, because they don't need to manually monitor and protect new virtual machines as they are created. As mentioned previously, Site Recovery Manager 5.8 allows for 5,000 virtual machines to be concurrently protected per vCenter, an increase from the 1,500 in Site Recovery Manager 5.5. In addition, up to 2,000 virtual machines can be concurrently recovered, an increase from the 1,000 in 5.5. Greater scalability means more protection for virtual machines in vCenter, and reducing the need to deploy more, smaller vCenter servers to protect all the required virtual machines. Another big change for administrators is that the vSphere client, sometimes called the C# client based on the language used to create it, is no longer required or even supported. In all previous versions, it was the only supported client. By moving to the new vSphere web client, Site Recovery Manager becomes a part of the family of products managed via a single interface, providing a single user interface to manage the environment. In addition to the basic user interface platform change, the new interface also simplifies array mapping when using array-based replication and makes bidirectional resource mapping much simpler. More information is provided in the interface, and a workflow guide to setting up Site Recovery Manager is also provided. The last big update for discussion is the new feature that enables you to update the IP address on each of your virtual machines when you fail them over. Previously, you updated IP addresses one by one. Now Site Recovery Manager can automatically assign a fixed IP address that is valid in the recovery site to a group of virtual machines. You simply define the subnet mask, starting and ending IP addresses, and Site Recovery Manager will automatically change the individual IP address for you. Now that you know what Site Recovery Manager is and all of its benefits, you need to know how to license the software. Site Recovery Manager is available as a standalone product or as part of the vCloud Suite bundle. If you purchase it as a standalone product, there are two editions to choose from, Standard and Enterprise, both of which are licensed per protected virtual machine. Site Recovery Manager Standard is limited to a maximum of 75 protected virtual machines per site, while Enterprise has no limits other than the Site Recovery Manager limits. Both are sold in packs of 25 protected virtual machines. If you want Site Recovery Manager as part of a bundle, you need to purchase the vCloud Suite Enterprise bundle. The lower editions don't include Site Recovery Manager. This bundle includes vRealize Automation, vRealize Operations, vCloud Networking and Security, vCloud Director, VCD, and vSphere Enterprise Plus. It is licensed per CPU, that is, per socket, out of the vSphere server, and can protect an unlimited number of virtual machines, again subject only to Site Recovery Manager limits. It's time for another knowledge check. Which of the following Site Recovery Manager components are required for storage-based replication? Select two options, then click Submit. This is the end of Lesson 2. You are now able to list the key components of a Site Recovery Manager solution, compare and contrast the replication mechanisms available with Site Recovery Manager, Describe how to achieve the desired outcome, test or failover, for each use case using Site Recovery Manager. Explain the possible dependencies between virtual machines during a failover. Describe the key new and improved features in Site Recovery Manager 5.8 versus 5.5. List the available packaging options for Site Recovery Manager. Thanks for taking the VMware Site Recovery Manager Fundamentals Course 5.8. You are now able to discuss the challenges of traditional disaster recovery, DR, as well as the capabilities and business use cases of Site Recovery Manager. Identify the terminology, core components, and high-level implementation requirements of vCenter Site Recovery Manager 5.8, including storage dependencies. Thanks for taking the VMware Site Recovery Manager e-learning course. Click Exit Course on the next screen.